Welcome, folks. Today, we're diving into a fascinating study about insulin resistance and non alcoholic fatty liver disease, or NAFLD. It's a complex topic, but a really important one for understanding type 2 diabetes. I'd heard a lot about NAFLD, but what exactly is the link between it and insulin resistance? Well, insulin resistance is when your body's cells don't respond properly to insulin, a hormone that regulates blood sugar. NAFLD, on the other hand, is a condition where you have too much fat stored in your liver, and this excess fat seems to interfere with insulin signaling. This study, led by Naoki Kumashiro and colleagues, really digs into the cellular mechanisms behind this connection. So, what were they trying to figure out specifically? They wanted to know if the same cellular processes that cause insulin resistance in animal models of NAFLD also apply to humans. They looked at things like inflammation, endoplasmic reticulum stress, that's stress, and the accumulation of lipids in liver cells. And how did they go about doing that? They took liver biopsies from 37 obese, non diabetic individuals and then correlated various markers of inflammation, stress, and lipid metabolism with a measure of insulin resistance called the Homeostatic Model Assessment of Insulin Resistance Index, or HOMA-IR. Okay, that sounds pretty comprehensive. What did they find? The most striking finding was that the amount of diacylglycerol, or DAG, in cytoplasmic lipid droplets in the liver was the strongest predictor of insulin resistance. In fact, it accounted for almost 2/3 of the variability in insulin sensitivity. DAG? I'm not familiar with that. What is it and why is it important? DAG is a type of lipid, a fat molecule, and it's found in different parts of the cell. The study found that DAG specifically within lipid droplets, these are like storage containers for fats inside the cell, was the key player. It seems that this DAG activates an enzyme called PKCE in the liver. PKC, another acronym, what does that do? PKCE is a type of protein kinase C, and it's involved in cell signaling. When activated by DAG, it interferes with the normal insulin signaling pathway, leading to insulin resistance. So it's like a domino effect. Excess fat in the liver leads to more DAG in lipid droplets, which then activates PKCE, and that blocks insulin signaling. Exactly. And what's interesting is that they didn't find a strong link between insulin resistance and other factors like inflammation or stress, at least not in this study. That's surprising because I've always heard that inflammation is a major driver of insulin resistance. You're right, it's a common idea. And the study did find some correlation between stress markers and insulin resistance, but it wasn't as strong as the DAG PKCE connection. It's possible that inflammation plays a more indirect role, or that its effects are more pronounced in other tissues. I see, interesting. So, what's the takeaway from all of this? The main conclusion is that hepatic DAG content in lipid droplets is a key predictor of insulin resistance in humans with NAFLD. This suggests that targeting DAG or PKCE could be a promising strategy for treating insulin resistance and type 2 diabetes in these patients. That makes sense, but are there any limitations to this study that we should keep in mind? Yes, definitely. The authors themselves point out that this is a correlational study, so it doesn't prove that DAG and PKCE cause insulin resistance. It's possible that they're both consequences of some other underlying factor. However, as the authors mentioned, animal studies do support a causal role for DAG-induced PKCE activation. Also, the study was limited to obese, non-diabetic Caucasian individuals, so the findings may not be generalizable to other populations. Got it. So, more research is needed to confirm these findings and explore their implications in different groups of people. Exactly. But this study provides valuable insights into the cellular mechanisms linking NAFLD and insulin resistance, and it highlights a potential new target for therapeutic intervention. Well, this has been really informative. Thanks for breaking down this complex topic for us. My pleasure. It's fascinating research, and it's important to understand these underlying mechanisms so we can develop better treatments for insulin resistance and related diseases. Thanks for listening, folks. Goodbye.